Homework set number 3. Although this is a hard collection of problems, but there is always an easy solution for most of the problems. So you can always give a trial and at least try to get the easy or the medium solution for a problem. In the first problem, which is an easy problem, you should find the minimum of a specific type. You should define a function. Let's name it find the smallest. The function will take a list of different items of different data types, and then it will take also a target type, and you should return the minimum among only the values of this data type, or none if it doesn't exist. For example, if I ask it to find the smallest of the list and give it the type of 0. 0 is an integer, so type of 0 will send here a parameter of type int. Now, which values here of type integer? 10, 20, and 5. What is the minimum among them? 5. 0.0 is float, so we have minus 2.5 and 5.2. The minimum is minus 2.5. Type of single quotes is a string, so the minimum of Mustafa and Ziad will be Ziad because the Z capital letter comes first. That's all. This is a simple exercise. In the second exercise, you will read a line of n integers. Let's call it list 1, and another line of m integers. Let's call it list 2. Then print yes if list 2 is subset of list 1. Otherwise, print no. And remember, the sublist is like substring. All of it as it should appear as one block in the list. For example, 1, 2, 3, 4 has 1, 4 doesn't have 1, 4 as a sublist because 1, 4 aren't consecutive, but 2, 3 is a sublist. Here 20, 25, 25 is a sublist, but 20, 25, 7 is a sublist because of the missing 2. Before learning about homework number 4, I would like to teach you a very common idea in computer science. We call it the sliding window. The sliding window is a window. Window means set of consecutive numbers. Like here, we have a window of these 8 numbers. And then we slide it to move to the next window. For example, notice here we moved 1 step. So now 1 is out, but 9 is in. And so on. If you slide it 1 more step, 2 is out and the 10 is in. And so on. This is a sliding window. We call it actually a fixed sliding window. There is also what we call a variable sliding window, but it isn't our business for now. Let's say we have a list of 103, minus 42, minus 6, and 9. And let's slide a window of length 3. So here is all the windows of length 3. 1, 0, 3. Then remove 1 and add minus 4. 0, 3, 4. Remove 0, add 2. 3 minus 4, 2. Minus 4, minus 2, minus 6. 2, minus 6, and 9, and so on. There is typically some operation requested on a window. For example, the sum. So the sum of this window is 4. The sum of this window is minus 1, and so on. And sometimes we would like to find, for example, the maximum among all of these windows. So the window of value 5 here from 2 minus 6, 9 is the maximum among them. Now in this task, you would like to read a line of n integers. Then in the next line, you will read integer k. And k is always less than or equal n. You would like to find the first window of length k that has the maximum sum. In the example here, the window start at, here is the input, this list, and the value 3. You should print something like starts at 4 with sum 5. Here, this window starting at index 4 has sum 5, which is the maximum. In this window, the window starting at length 0, index 0 with length 4 has a sum of 26. This problem is like a medium to hard. Can you do it without nested loops? This is by itself has 2 solutions, and they aren't very easy solution. One of them is based on the observation that we mentioned in the previous slide. So try to solve it with nested loops as an easy solution, then try to find one of these 2 solutions here. Counting increasing subarrays. You will read a line of n integers and you would like to count how many sublists are increasing. Let's say that the input is 1, 2, 3, 4. And let's generate all the different sublists that we have. You can think of that as all of the different windows of all of different sizes. So for all the sublists of length 1, we have a list of 1, 2, 3, 4 here separate. Of length 2, we have 1, 2, then 2, 3, then 3, 4. Of length 3 we have 1, 2, 3, 1, 2, 3 and 2, 3, 4. Of length 4 we have only 1, 2, 3, 4. If you counted all of them, you will notice we have 10 different sublists. All of them are increasing. If I change this order to be decreasing to increasing here, there's only now sublists of length 1 that are valid. And for this one, we have an answer 6. Again, there is an easy solution using 3 nested loops, and then a medium solution using 2 loops, and a hard solution using 1 loop. And remember that you will have difficulties to develop the hard solutions and even many of the medium solutions. Take it easy on yourself, try, read my solution, come back later with the things that you couldn't solve or understand. Homework number 5. There is a very popular problem in computer science. We call it Joseph problem. In a Joseph problem, you need to read 2 integers, n, which is here a small value, and k, which is a very large value. But I would like for your initial trial to think in k only like something like maybe 10 or 100, something small. This is a game as following. We ask people to create a circle from 1 to n. So imagine that we have now 4 people in a circle 1, 2, 3, 4. There is someone who is called the master of the game. That guy starts at person number 1 and to count the k times. And at the kth person, he just remove him from this circle. For example, if the circle here, the last guy, by the way, is called the winner. Let's say that the input is 4, so 4 persons in a circle, and the counter is just 2. So the guy do as following. He start at position 1 and count 2. 1, 2, then this person will be removed from the list. Now we are at line at 3. Count 2, 1, 2, then we remove 4 from the list. We are now at the next one here, which is 1. Count 2, 1, 3, we remove him, so 1 is remaining. So you should print the order of the people removed. We removed the 2, then 4, then 3, then 1. I'm here giving several input test cases to make sure that your overall is really running. The last 2 test cases might be a bit tricky, especially the very last one. You need to find a way to handle the very large k so that the last case work very well. Homework number 6, you would like to find the longest sublist or the longest subarray. Read a line of n integers. Each integer is just 0 or 1. You would like to find the sublist with numbers of zeros equal numbers of ones. For example, let's say that you read this input here. Notice here this last sublist, it has 3 zeros and 3 ones. So this is the longest sublist that has number of zeros equals to number of ones. In this second input, observe here this, for example, sublist has a number of zeros equal number of ones. They are all 4. In this example, we have nothing equal to zeros and ones, so the answer is 0. In this case, the last 4 items have a value of 2 zeros and 2 ones, and so on. So this is your problem. The problem is easy with 3 loops, medium with 2 loops, but very hard with single loop. Another interesting question is, how can we reduce this problem to another problem? The idea of reduction is a very common idea in problems in computer science. You have a problem and we can convert it to another equal problem. So I'm asking you here, can we reduce it to another problem, which is the longest sublist of the zero sum? Here we would like to find the longest sublist with zeros equals to ones. I'm here asking you to convert it to the longest sublist of zero sum. That's all.